Hello, everyone. My name is Munish Chandel. I'm a faculty at Environmental Science and Engineering Department. And in today's lecture, I will talk to you about separation, processing, and transformation of municipal solid waste. As in your previous lecture, you have learned about waste generation, waste handling, separation, storage, and processing at the source and collection and how the waste is transferred and transported. And now we will talk about in this lecture about separation, processing, and transformation of solid waste and the ultimate disposal of the waste. So let's get started. So this separation, processing, and transformation many times is loosely also called treatment of municipal waste. So, for treatment of municipal solid waste, we use different types of physical, chemical, as well as biological method. Let me highlight some of them. For example, you want to do physical processes or physical method. Uh, this table shows the transformation process and the method used and the potential products we got from the transformation. So for example, the first transformation process is component separation. And the transformation method is either manually or using different mechanical tools. And the transformation products, as the name indicate, is individual components of MSW. Similarly, other physical methods are volume reduction. How can we reduce the volume? By applying energy in the form of force or pressure. And what we will get out of it, we will be able to reduce the volume as compared to its initial form. Similarly, if we want to reduce size, we can shred or grind or mill the waste by applying different by energy in different ways. And obviously, what we will get is the smaller size MSW, or you can say the reduced size particles or materials of MSW. Similarly, in terms of chemical method, the most widely used chemical method for municipal solid waste is combustion. As you all are aware about combustion, it's basically a thermal oxidation process. In this process, you basically oxidize your municipal solid waste and eventually you convert it into carbon dioxide, sulfur dioxide, and other oxidation products. And the residue remaining is ash. So basically, it's a complete combustion. This is also called incineration. In place of combustion, if we do partial oxidation or also called starved air combustion, so then you do not completely oxidize the waste, but you convert into partially oxidized gas, which is called synthetic gas. And this synthetic gas largely contain carbon monoxide and hydrogen, and it further can be used as a fuel, as a gaseous fuel for other applications. In addition to getting this synthetic gas, you also may get or would get charcoal containing carbon and inerts and some kind of oil also. Uh, the third process, which is also coming into picture, or maybe you can say that now we have started using it, is called pyrolysis. So what is pyrolysis? It's the destructive distillation. We do not supply uh, any oxygen or any air. For example, in combustion, we were completely oxidizing. In gasification, partially oxidizing. In pyrolysis, no oxidation actually, no supply of oxygen or air. And we simply heat the waste at a very high temperature. And this eventually convert your waste into a pyrolytic oil, which is the main objective here. Along with that, you get char and the pyrolytic gases and some tar also. We will talk about these processes a little bit later. The third most important method is biological method, and I would say for municipal solid waste, one of the most important way of transforming the municipal solid waste. So as the first and most important is composting. As all of you are aware about composting, it's basically an aerobic biological conversion of your municipal solid waste into a stabilized material, which is called compost. It's a basically humus-like material, and it can be used as a soil conditioner or organic fertilizer. The second method is anaerobic digestion. It's basically an anaerobic process. You basically, in the absence of air or oxygen, you, in the presence of bacteria, using anaerobic bacteria, you convert your municipal solid waste or biodegradable municipal solid waste into methane and into carbon dioxide. And we also get some other trace gases as a digested humus or sludge, which further can be processed and used as a compost. So first of all, we'll talk about some of these physical methods which are used in waste separation and processing. So there are several unit operation used for the separation and processing of waste materials. Some of them are shredders, crushers, grinders, screens, separators, and balers. So first, let's talk about the shredders. As the name indicates, it basically is used to shred the waste into so that we can reduce the size, and then maybe the waste can be used for further applications after. So there are different types of shredders. So three are named here, and they are more widely used for municipal solid waste: hammer mill, flail mill, and shear shredders. If you see here, this one is basically hammer mill. So, you can see there are hammers. There are basically hammers used. You can see these hammers. They are on a rotating shaft, and there is an adjustable brake bar. So what basically happens is this shaft rotates, and these hammers hit the waste, and what size waste you want, that will depend upon the breakable bar adjustment. And based on, there is a grate with openings in the bottom, and the final materials, once it is shredded, it goes out, and the remaining keep on hit by the your rotating hammer. So this is an hammer mill, largely used for little bit tough materials or hard materials. Similarly, you have flail mill. You can see flail mill here. You have basically flail. Again, you hit the waste with a hammer of flails, and again the more or less same process. It also can be used for bag opening or for bag breaking. And the third one is the shear shredder, where basically we tear the waste by using the shear forces. You can see this, for example, is how the horizontal hammer mill look like. You put your waste, it gets hammered, and then the final material goes on. This is a better picture of a shear shredder. You can see there are basically uh, cutters, which are one part is moving in clockwise and another in anti-clockwise. So basically, it tear or it cut the waste into small pieces and is processed further. Then there's another unit operation used for separation and processing is glass crusher, as the name indicate. Glass is often crushed after it has been separated to reduce storage and shipping cost. And in many times, in when we are doing several mechanical separation operation, glass is crushed after one or more separation steps so that it can be removed by screening. This crushed glass can also be separated by using optical sorting. Uh, However, if your waste is commingled, that may not be that efficient and accurate, and maybe a little bit more expensive. But never then optical sorting can be used for glass separation. Then the another unit operation is which is used for municipal solid waste is wood grinder or wood chipper. As the name indicate, it basically shred large pieces of wood into small chips so that it either can be used as a fuel or maybe a finer material which can be then composted later. Then one important unit operation which you will quite often see in material recovery facilities of municipal solid waste is screen. Actually, you will find there are several screens uh, in your MRF material recovery facility, and they are basically, as the name indicates, to separate mixtures of materials based on their size. So there are several applications of screening. For example, removal of oversized and undersized materials, separation of waste into light combustible and heavy combustible, recovery of paper, plastic, and other light materials from glass and metal, separation of glass, grit, and sand from combustible materials so that you can improve the efficiency of combustion system, removal of oversized materials from combustion ash. So as you can see, there are several of these applications. So therefore, you will find not one, two, but several types and several of screens in your material recovery facility or in your waste management facility. So the most commonly used screens for municipal solids are bibratory screens, and the second one is rotary or trommel screen, and the third one is disc screens. The disc screens are also called self-cleaning screens, and you can adjust the space. That means adjust the space between the disc, and therefore you can choose the different sizes in a single screen. So this is the top one is the vibratory screen. As you can see, the vibrating force is used to separate the material. You feed the material on a screen, and the final material will pass through it. You keep on vibrating, and maybe you can use multiple screens here. So that is based that are the vibratory screen. The waste is removed based on the size. Similarly, you have rotary screen or trommel screen, most commonly used. You can see this is a rotary or common screen. There are size or there are slots on this. You can say the different size slots, for example, smaller and larger. You feed it, you rotate it very slowly. The idea of rotation is just to make sure that there is no mix or the ample mixing is taking place. The underflow material is separated, one size here, for example, the second size here. The third one, which is shown here, is basically disk screen. So as there are different disks and there is a space between these disks and the material pass through these screens. As I mentioned in the last slide, this size is a variable depending upon the setting or the how close or how far are the disk. So these three ones are used in your municipal solid waste. This is a real picture taken of a trommel screen. This is how it looks from inside, and you will see that several of these trommel screens are used, for example, here for cleaning or for doing the size reduction after composting. Then another unit operation used for the separation and processing is air classifier or density separator. As the name indicate, you separate the material based on their density. So what you do in the air classifier, you can see here, for example, you have a mixed waste and shredded waste, you put it in and then you pass air. So what happens is the lighter materials, it flows along with air and you take it to a large cyclone separator. Basically, you are increasing the area so that the material which was flowing with air, it will be separated and the air will go out. And here the heavy materials which cannot flow with the air, they will fall down. So by this, you will collecting the heavy material here and the lighter materials like paper, plastic in another chamber or another conveyor belt. You sometimes also use magnetic separation for removing ferrous materials from other materials, maybe from a separated waste or from commingled waste or even from the shredded waste. So this is an example of how this looks like. You have mixed waste, you put it, pass it through a magnetic belt or a magnetic field, and your ferrous metals will be captured and they will be separated, and other non-ferrous material will fall on another conveyor. So basically, you are passing the ferrous material here on one conveyor and the non-ferrous on another conveyor. So if you want more efficiency, because this is again, as I mentioned many times, mixed waste, so you have to use them maybe at least 2 or 3 in series so that there is a better clean material. So you can see, for example, you are taking the ferrous material here. Again, you are using the magnetic field, lifting it. Again, the ferrous material is gone and the non-ferrous material is separated. So this is basically to improve the recovery efficiency of ferrous materials. We have to use these magnetic belts, maybe 2, 3, or depending upon your system. Similar to this, you also use compaction systems, densification, and there are several way of doing densification. The idea is so that it increases the density of the base so that it can be stored and transported more efficiently and economically. There are basically several ways: pelleting, baling. So, for example, in a balers, what we basically do is we reduce the volume of the waste for storage, prepare the waste for marketing, and increase the density of waste, thereby reducing the shipping cost. So basically, baler is to compact waste and reduce the volume and hold it in a proper way so that it can be easily transported, etc. And what kind of material we generally bale? Paper, cardboard, plastic, aluminum, and tin cans, and even large metal components. So this is a typical baler. You can see here, this is basically it is the waste is passed through a baling machine, and it comes out. It's compacted, and after that, you can see here, for example, it is tied down by a buyer, and then so that it can be easily transported to different places, to far distance places for using for different application, even as a fuel. This is called baler. Similarly, you also use cane crushers, as the name indicates, for these aluminum and tin cans. We basically to just increase the density and reducing handling and shipping cost. You have machines which basically keep on crushing them and then put it into a large trucks or trailers and ship to a distance. Now you have understood several of these physical separation methods, and which method we'll use and how many of them, it will depend upon what is our objective function. So when we're talking about separation, we generally have separation which is done at the source level, which you must have studied in the previous lectures. And you also have a source or a separation of these material at the facilities which we call material recovery facilities. So basically, material recovery facilities are largely the larger ones. That source can be your house or a kind of society where you are separating the waste. So when we are doing this separation at the source level, we mostly do it manually. That means some people will be doing it. At material recovery facility, we can use the combination of manual as well as mechanical methods, which we talked in the previous slides. And these MRF facilities or material recovery facilities are used for further processing of source separated waste. So what happens is, once your waste, even if it is source separated, it still has many impurities. So still it can be further processed in your MRFs, or MRFs can be used for separation and recovery of reusable and recycled materials from commingled MSW. Commingled MSW is that you have got mixed waste. So these MRF facilities can be used to separate these materials as different kinds of material which we were discussing, and improving also of the quality of the separation. So for example, there already is a dry and wet waste separation, but you want to further improve the quality of the separation. You can use those methods or different separation methods at the MRF facility. So there are different types of MRF facilities. It will all depend upon what kind of waste you're getting. Are you getting a source separated dry waste, or are you getting a mixed paste where there is a dry and wet together? And there can be several complex to very simple MRF facility depending upon our requirement. And what kind of MRF we have to depend or develop, it depends upon the number and types of components to be separated. Your waste diversion goal, that means how much waste you want to recover, and the specification of materials for different application in the downstream side. And the more important, this whole will depend, if you look into with the economic perspective, with the cost of or economics associated. For example, you can have very sophisticated MRF facility, but then if there is no market for these separated materials, so therefore it will not be that wise to have those kind of sophisticated facilities. But if you can separate materials and there is a market for separated materials, you can have a really sophisticated MRF facilities. So it also depends what you're doing with the source or with the separated material and the separated products. So with this, that's all I would like to tell you about uh, the different physical processes. We talked about physical, chemical, and biological processes, but we talked about several physical processes or physical methods which are used for separation or transforming the waste. In the next lecture, I will talk, or in the next part of this lecture, I will talk about the biological processes. Thank you. I will stop here.